Geometry class, here's part 2 of section 9-1 notes. A lot of simplifying radicals type thing. Let's move into part 2. Let's talk about the quadratics. All right. In math, anything that has x squared involved is called the quadratic equation. All right. Has x squared is the highest degree number. If it has x cubed, then they call it a cubic equation. If it has x to the fourth, they call it quartic. But quadratics is a big part of Algebra 2. And so if you just took Algebra 2, this is going to be instant flashback for you right here, okay? How to solve a simple quadratic, all right? Simple quadratic, let's go example F. Example F, solve for x. This would be the simple example. So it has only x squared, no x term. It has only x squared. So in this example, if I give you x squared plus 9 equals 25. X squared plus 9 equals 25. You're going to isolate the x squared part. Get that by itself. And then we're going to square root both sides. Now, if you throw a square root over both sides of an equation, and you get it down from x squared to now just x, the other side, all right, it's really this side, but you're going to divide it over to this side. The other side needs a plus minus. There are two possible answers when you do x squared. One's positive 4 and one's negative 4, all right? So that plus minus is going to be very, very important for us. All right, there's a simple example for you. So let's do another one. Let's take it up a little bit of a notch here. EF, let's do G, example G. Just hear me doing the alphabet in my head. Solve for x again. If I give you 3 square root of 5 squared plus 3 square root of 2 squared, and that equals x squared. Again, you have x squared all by itself. Okay, so we're going to simplify this side and then square root it. So what you cannot do, you can't throw a giant square root over the left and the right and say the squareds are canceled. Can't do that. All right, that wouldn't work up here either. Like if I did x squared equals 25 minus 9, and hey, that's 5 squared, and that's 3 squared. That's x squared, and then I just go square root the whole thing, and x equals 5 minus 3, and x equals 2. That's not correct. Doesn't work. Won't work here either because of that plus sign there. Now, if I get it down to one term on this side and one term on that side, then I can square root both sides. So what I need first is to simplify it. I need to square this and square that, add them together. So I'm going to square this side. You have to square both this part and this part. So that's going to give me a 3. That's going to give me a square root, not 3, that's going to give me a 9, 3 squared, hello. And then square root of 5 squared is like the square root of 25, but that's going to equal 9 times 5, and you get 45. Do that again, we're going to square this. So when you go 3 root 2 times another 3 root 2, 3 times 3 is 9. Square root of 2 times square root of 2 is square root of 4, but that just equals a normal 2. So I get 45 plus 18 is equal to x squared. When I add those two parts together, I'm going to get the square root, not square root yet, I'm getting ahead of myself. 63 is equal to x squared. Then I square root both sides. Got ahead of myself. So this is going to be x. This side's going to need a plus minus. What perfect square goes into 63? It's going to be 9 times 7. So the square root of 9 is 3. And the square root of 7 stays square root of 7. And so my answers are plus and minus 3 root 7. Plus and minus 3 square root of 7. There are two answers to that problem, not just one. How about example H? Solve for x. Notice we're not writing decimal answers down. All right, that one isn't a decimal anyway, but we're not writing a decimal answer down. We're doing simplest radical form. Simplest radical form. That's how we're answering all of these questions. Just simplify the radical. Solve for x. Now, this is a quadratic equation type problem. So if I have x squared minus 10x equals negative 16. Now, that's where you have an x squared, you have an x, and you have a number without an x. There's two ways we could do this kind of a problem. So I could do factoring. And that's what really you need to know how to do factoring. I teach pre-calculus. So many of you are going on to pre-calculus. You got to know how to do your factoring. So set one side equal to 0. X squared minus 10x plus, you have to add that over, plus 16 equals 0. And you think to yourself, little product sum rule. What are two numbers? There's a 1 in front. So 1 times 16 is 16. And negative 10 is the middle. You think, hey, what are two numbers that multiply to be 16, product, and their sum is negative 10? Well, if they multiply to be positive 16, they got to be the same sign. And if they add to be negative 10, they got to be two negatives. So it's got to be negative 8 and negative 2. If you multiply them, you get 16. You add them, you get negative 10. That's going to be your two parentheses. X minus 8, x minus 10. Those are your two factors. And then you should have learned a long time ago, Algebra 1, zero product rule. If you have two things multiplied together and equals 0, that means either the first one's 0 or the second one's 0, or maybe both. So if I have two parentheses multiplied together equals 0, either this one equals 0 or the other one equals 0. So x equals 8, x equals 2. Now the other way you could solve this problem is not by factoring. You could use a quadratic formula. Now the quadratic formula should only be used if you can't factor. Not everything is factorable. What if there was no combination for this product sum? Then you have to use quadratic formula. In case you forgot, it's the opposite of b plus or minus the square root, b squared minus 4 times a times c, all over 2a. And remember, it's a and then b and then c. Well, actually, you have to have it set equal to 0. So a, then b, and then c. So a is 1, b is negative 10, c is 16. So negative b means opposite of b. That's going to be 10 plus or minus the square root of negative 10 squared is 100 minus 4 times 1 times 16 divided by 2 times 1. X is going to equal 10 plus or minus the square root of 100 minus 64 all over 2. That's going to give me x equals 10. Is this on screen? Yeah. Plus or minus square root of 36 all over 2. 10 plus or minus 6 over 2. Now, if I add those numbers on top, 2 plus 6, that's 16 divided by 2, which is 8. If I subtract those two numbers on top, 10 minus 6, that's 4, and 4 divided by 2 is 2. So I get answers of 8 and 2. I get answers of 8 and 2. There is almost always a whole lot more chance of getting this wrong. All right, when you have that many steps, that many signs to take care of, you're much better to try factoring first. See if it factors first before you try to do the quadratic formula. Let's move along before I run out of time here. All right, example I. Solve for x. This is an example where there's no c term. All right, there's no constant term. I got x squared plus 5x, and that equals 0. You could do the quadratic formula. A is 1, B is 5, C is 0. Like this part's missing. The A, B, and the C part's missing. But this is a really easy problem. Take out the common factor. They both have an x. Take it out. And you go x plus 5 equals 0. These are two factors, two things multiplied together. This and this equals 0. So either this one equals 0 or this one equals 0. So one answer is 0, and the other answer is -5. Subtract 5 to the other side. All right, I got to rush through the last two so I don't run out of time. I got to end it in the 14-minute mark here. So, example J, solve for x. If I go x squared minus 5x equals 24. I want to set it equal to 0. Think product sum. Hey, what two numbers multiply to be -24, but when I add them together, I get -5. All right, that combination, let's see, it's going to be one positive and one negative. There's going to be -8 and +3. And so I go x minus 8 and x plus 3. You can also do FOIL in your head. That'd be x squared plus 3x minus 8x. That equals -5x. Then set each one equal to 0. This parentheses equal to 0. That parentheses equal to 0. I get x equals 8. X equals -3 for my two answers. This is all a review of factoring from Algebra 2. All right, last example. Last example here. Let's go example K. Solve for x. And I've got 2x squared plus 11x plus 5 equals 0. A little bit difficult. So if you're in class, I'll teach you another method. A lot of teachers, they teach this guess and check thing. Like, all right, you got 2x here. So the only way that works is if it's 2x and x, and you got a 5 here. So the only way that works is if it's a 5 here and a 1 here, or a 1 here and a 5 here, and you go back and forth. When you FOIL it, the middle terms, all right, the middle terms have to be 11x. So the combination is going to be, let's see, I need a 10 and a 1. So plus 5 here, plus 1 here. So you go 2x plus 1 equals 0, x plus 5 equals 0, x equals -5. Subtract 1, divide by 2, x equals -1/2. I teach a whole new method. This video is not going to do it justice because I'm running short on time. But I would take 2 times 5 to do product sum. 2 times 5 is 10. The sum is 11. And so the combination, 2 times 5 is 10. The combination is 11. It's going to be 10 and 1. 10 times 1 is 10. 10 plus 1 is 11. And what I do is I split this middle up. Instead of using 11x, I say, well, I'm going to use 10x and x. And then I do something called factor by grouping. Group the first two, 10x squared plus 10x, 2x squared plus 10x. I take out a 2 and an x. I get x plus 5. This one I don't have anything in common to take out, so I'm just going to take out a 1. These parentheses match, so that's one of the factors. These outside numbers is my other factor. Then I set those equal to 0. All right, this whole thing should have been equal to 0 the whole time. And we end up with the same two answers. X equals -1/2. X equals -5. All right, I got to end it there before this video glitches on me when it goes past 14:30 mark. But that's the end of the notes for section 9-1. Let me know if you have any questions.